to 0. And then you have that finally b plus 2c should be equal to 1. This is a constant term here. This means that this is a is equal to minus b, or b is equal to minus a from this equation. So you have that b is equal to minus 1/2. And if you put this into this equation, you get minus 1/2 plus 2c is equal to 1. And this means that c is equal to 3/2. I put 1/2 on the other side, or 2c, and then I get c equal to 3/4. So you get the solution 1/2 t squared minus 1/2 t plus 3/4. And here you can see that this linear term is needed. It's actually different from 0 if you put it. So when you're going to guess on a polynomial solution, then you should guess to that the order that is necessary, and the order that is necessary here is a second order, but then it should be the most general polynomial that you use in your guess. And you can say, okay, it took some work, but there was no integration. You didn't have to compute these rather difficult integrals, so it's easier. Let's take the second one, where the right-hand side now is cosine 3t. Here I will guess, because if you have a trigonometric function and you take the derivative, yeah? Yeah. Thank you. Yeah. So when you take the derivative of a trigonometric function, you get a trigonometric function. So, and since you have the function itself in the differential equation, in the left-hand side of your equation, then you probably need a term like cosine 3t. But if you take the derivative of cosine, you get sine. So you will also need such a term. And this is when you take the derivative, you get this is a composite function, cosine of 3t. So you have to multiply by the derivative of this 3t, so you get 3 outside. But you keep the argument 3t. So this is probably the most general form of the solution that you can think of. Let's try that. Let's put it into the equation. So I need the derivative, and the derivative of this one is minus a times sine of 3t times 3. And that is the derivative of cosine is minus sinus, and then you have the factor 3 here. And then the derivative of this one will be cosine, so that will be 3b cosine 3t, and then 2 times the function itself, which is a cosine 3t plus b sine of 3t. let me just put these like this. And this should be equal to the right-hand side, which is then cosine 3t. So let me collect terms with cosine. You have 2a here, 2a, and then you have plus 3b. And this should be equal to cosine. And then again you have minus 3a, and then you have plus 2b. And since there's no sign on the right-hand side, sine of 3t, then this should be equal to 0. So this should be equal to 1, and this should be equal to 0. That gives you two equations and two unknowns, and you can write the augmented matrix, and you can do all the stuff there. But let's just solve this problem by saying that if you take that minus 3a plus 2b is equal to 0, then b is equal to 3/2 of a. I put this on the other side, and then I divide by 2, and I get 3/2 of a. And if I put this into the first equation, I get here, let me write this here, I get 2a plus 3 times 3/2 a, this is b, and this should be equal to 1. That is the coefficient to this on the right-hand side. And this is an equation where we can isolate a. You get 2 plus 9/2, or I have put a there, 1. And this is 2, this is 4, 13. So a is 4, or is 2 divided by 13. And when I have a, I can compute b. And I multiply this by 3/2, I get 3 divided by. So this is my x2 solution, which is 2 divided by 13, then plus 3 divided by 13 times. Again, there are some computations, but they are easy computations. And it becomes even more easy when you look at the third problem. You have the exponential function, but when you take the derivative of the exponential function, you get the function itself. So a natural guess for the third function, you see the third, the right-hand side is e t. So if we guess this function here, that might work. All right. So let us put it into the equation. I have to take the derivative of this one, and it's the function itself. And then I have to take 2 times the function, and this should be equal to the right-hand side. And here I can, it's always a positive number, so I can divide by this, and I get that 3a is equal to 1. That is, a is equal to 1/3. And this gives me the solution here for the third part of the particular solution. Now I'm able to write down the complete solution. You have x of t is equal, and let me take x1. I have x1 of t here, so it'll be 1/2 t squared minus 1/2 t and plus 3/4. And then the second solution here, which is 2 divided by 13 times cosine plus 3 divided by 13 times sine of 3t. And then finally, or not finally, but I need this term here. And not finally, because I need the solution to the homogeneous problem, and that was k times e to minus 2t, and k is just a real number. So this is the complete solution to this problem. But again, if you want to use this method, and if you're asked to use this method, then you should use your judgment. You should divide the right-hand side into sensible portions where you can guess a solution to that problem, and then having found the solution, you can add it up to the full solution. And this is called superposition. Now, the question now is, does this always work? Does it always work? Can you always, if you have such a right-hand side, can you then find a solution to the equation? Well, it works, but sometimes you have to do something special in order to get the solution. So, and let me give you an example on this. You have again this left-hand side of your differential equation, but now the right-hand side is okay, it's an exponential function. So the guess would be a to, if you put this into the equation, then you will get, if you take the derivative of this, you get minus 2a. This is the derivative of this function, and then you have to add 2a, and this should be equal to e to minus 2t. But these two terms cancel, and you get 0 equal to Can anybody tell me why this is? Well, it's because this is a solution to the homogeneous problem. Whenever the right-hand side, you have a function at the right-hand side that is a solution to the homogeneous problem, then you cannot just guess this right-hand side in this fashion. But what can you do then? Let me see. I don't have the general solution formula, but let me write this down then. You have e to and then you have e to and then so this is the general solution formula. So let's look at this and see if we can come up with a solution to this problem, or we could make a different guess on our solution. In our case, our p of t is equal to 2t. This was the integral of this function here, which is 2t. And then this integral here will be e2t, and then times q of t, which is e to minus 2t. And if you multiply these two together, you get 2t minus 2t, which is 0. So this is equal to 1. And if you integrate 1, you get t. So your complete solution tells you that you should have a particular solution which is t times the solution to the homogeneous problem. Here you have the solution to the homogeneous problem, and the structure would then be that you have t times the solution to the homogeneous problem. So let's try that. Let's try a solution of the form a and then times t times e to minus 2t. So this is a guess, and I should call this a particular solution. Let's put it into the equation. Here we have to take the derivative. This is a product, so I have the derivative of a times t, that is a, and then I keep this one, 2t, and then I keep at, and then I take the derivative of this one, and this is e to minus 2t times minus 2. So this was the derivative of the function, and then I have to add 2 times the function, 2a e to minus 2t. And now you see that here you have 2a e to minus t, and here you have minus 2a. I have to put in, of course, this function here. So it's a times t times e to minus 2t. So these two terms cancel, and I end up with a to e minus 2t, and this should be equal to, and this means that a is equal to 1. So whenever you have a solution that is, or you have a right-hand side which is a solution to the homogeneous problem, then you should guess on a solution that is t times this solution. Okay, this was what I had for you today, but today we will have a small evaluation on your group exercises, and I think this room here is available at 1 o'clock. So the TAs and I will be here at 1 o'clock and we'll conduct a short oral evaluation. Okay, thank you.